All right, everybody, welcome back to the 2023 FRQ free response. We left off with question number 5. So, um, yeah, let's walk through this one. So it says the functions f and g are twice differentiable. The table shown gives values of the functions and their first derivatives at selected values of x. Let h be the function defined by h of x, which is f of g of x. Find h prime of 7. All right. Part A is a pretty straightforward question. We're given a function for h of x, and all we have to do is find the derivative and evaluate it at 7. So let's go ahead and start by writing our function. H of x is f of g of x. Now, take the derivative. But because f of g is a composition of functions, this is where you apply the chain rule. So we have f prime of g of x times the derivative of the inside, which is g prime of x. Now take your 7, plug it into the function. F prime of g of 7 times g prime of 7. And because we're not given an actual function for either of these, this is where you have to utilize the table. So let's take a look. G of 7 is 0. So let's go ahead and plug that in. F prime of 0. And then g prime of 7 is 8. So times 8. All right. So now we got to evaluate f prime of 0. Looking at the table, that is 3/2. So 3 over 2 times 8 equals 12. Let's take a quick look at our solutions just to make sure everything checks out. And we're good. Okay, part B. Let k be a differentiable function such that k prime of x is given by the following equation. Is the graph of k concave up or concave down at the point where x is equal to 4? Give a reason for your answer. Okay. So since we're talking about concavity, this tells you that we're going to be looking at the second derivative. We already have the first. So the first thing I'm going to do is just go ahead and write my given derivative. And then we're going to derive it. Be careful with this one because right here we have a product rule and we also have a chain rule involved. So it's the first times the derivative of the second plus the second times the derivative of the first. And that's 2 f of x times f prime of x. Okay. We don't actually have to simplify this since we're looking for concavity at a specific point. So just go ahead and plug in 4. So k double prime of 4 is equal to f of 4 squared times g prime of 4 plus g of 4 times 2 times f of 4 times f prime of 4. Okay, lots of stuff here. All right, so we're gonna have to be using our table here. Luckily for me, I have one next to me. All right, so f of 4, let's see. F of 4 is 4. G prime of 4 is 2. G of 4 is negative 3. F of 4 is 4. And f prime of 4 is 3. All right. Now go ahead and simplify all this. 16 times 2 plus negative 3 times 8 times 3, that's 24. Okay, this is 32 minus 60, 72, which is negative 50. Let me check my answer real quick. I feel like I made a mistake somewhere here. Let's see. First times the derivative for the second plus the second times the derivative for the first. F of 4, G prime of 4, G of 4, F of 4, F prime of 4. Okay. No, I think we're good. Okay. So we have a negative second derivative. And here's the interpretation of this, right? Since K double prime is negative, then that means that our function is going to be concave down. The graph of K is concave down. There we go. And you guys make sure to double check the rubric so that you can see what we're giving points for, right? Because there's always certain parts. But let's go ahead and move on to question C. Let m be the function defined by m of x. Find m of 2 and show the work that leads to your answer. All right. So don't overthink it, right? We want to find m of 2. And we already have a function for m. Start by plugging it in. M of 2 is equal to 5 times 2 to the power of 3 plus the integral from 0 to 2 of f prime of t dt. Okay. The first part of the function is pretty straightforward. We're going to get 5 times 8. But for the second part, for the integral, we got to take our antiderivative, right? And the antiderivative of f prime is simply f of t, evaluated from 0 to 2. So this gives us 40 plus f of 2 minus f of 0. And according to the table, f of 2 is 7 and f of 0 is 10. So this gives us 57. All right. Wait, give me a second. F of 0 is 10, but I changed the sign right here. It should be minus 7 minus 10. So then we have 47 minus 10, 37. Oof, almost missed it. Okay. Part D. Is the function m defined in part C increasing, decreasing, or neither at x equals 2? Justify your answer. So m of x is 5x to the power of 3 plus the integral from 0 to x of f prime of t dt. In order for us to figure out if the function is increasing or decreasing, we're going to have to take the derivative of this. So m prime of x is equal to 15x squared. Okay, be careful right here because this is a part of that, although it's simple, we kind of missed it a lot in the last quiz that we took. Let me get back to it. Okay, the derivative of the integral, remember, it basically just cancels out the integral, but the x gets plugged in. So then we have f prime of x. Now plug in the 2, which is 15 times 2 to the power of 2 plus f prime of 2. Okay, the first part gives me 60. But the second part, we're going to need our table. F prime of 2 is negative 8, which is 52. Okay. All right. So we already know that the velocity here is positive, right? Positive 52. So that already That already tells me that the function is increasing, but just to make sure, we're also going to go ahead and take the second derivative. M double prime of x is equal to 30x plus f double prime of x. And we're going to, again, plug in the 2. Oh, wait a moment. I don't think I have enough information for this. A second derivative of f on my table. Nope, I don't have it. So I guess this part, never mind. We don't need it. So since m prime of 2 is positive, then that means that m of x is increasing. Okay. And that's the end of question 5. All right, one more question to go. Question 6. Consider the curve given by the equation 6xy equals 2 plus y to the power of 3. Show that dy dx is equal to this given equation. Okay. So for this question, we have to apply the idea of implicit differentiation, where whenever you take the derivative of a function that is not x, you're going to get a function that is dy dx, right? Or just y prime. So let's go ahead and start this process. The derivative of x times y. Use the product rule. The first times the derivative of the second plus the second times the derivative of the first equals the derivative of 2 is 0, but the derivative of y to the power of 3 is 3y squared times y prime. Okay. From here, just manipulate the equation so that you solve for y prime and then you get it on one side, right? So 6xy prime plus 6y is equal to 3y squared y prime. Take away 6xy prime from both sides. 6xy prime. Okay. Right here, notice how we have a greatest common factor, right? We're going to go ahead and take out a 3y prime. And this leaves us with a y squared minus a 2x. Last but not least, oh, just kidding, 2 more steps. Divide by y squared minus 2x. This equals 3y prime. You gotta see, last but not least, divide by 3. And when you divide by 3, we're going to get 2y over y squared minus 2x. And is that what the derivative was? Yes, it is. Perfect. Okay. B. Find the coordinates of a point on the curve at which the line tangent to the curve is horizontal, or explain why no such point exists. Okay. The key thing right here is that we want to find the coordinates of a horizontal line. And what do we know about horizontal lines? We know the slope is 0. So let's start with that, right? We know that dy dx is equal to 2y over y squared minus 2x. But we also know that we have to make dy dx equal to 0. So 0 is equal to 2y over y squared minus 2x. All right, let's solve for y. First, multiply both sides by the denominator. And that gets us 0 is equal to 2y. Next, divide by 2. And there's your y coordinate. Now, to find the x coordinate, you're going to have to go back to the original function, which was 6xy equals 2 plus y to the power of 3, and plug in the 0. 6x times 0 is equal to 2 plus 0. This is interesting because we get 0 equals 2, and that doesn't make sense, huh? So, since the value of x is undefined, then there is no point such that the tangent line is horizontal. Okay, so it's right here, undefined. Part C. Now we're going to have to find the coordinates of a point on the curve at which the line tangent to the curve is vertical, or explain why no such point exists. Okay, so now we have a vertical line, a tangent line, right? So from a tangent line, we know that the derivative or the slope has to be undefined. In other words, the denominator of the derivative must be set equal to 0. So we start with our derivative. dy dx is equal to 2y over y squared minus 2x. Make the denominator equal to 0. And now you can solve for whatever you want. You can either solve for x or you can solve for y. I'm gonna go ahead and solve for x. So let's add 2x to both sides. 2x is equal to y squared. X is equal to y squared over 2. Okay. This is basically step number 1. We don't have an actual value yet, but we do have something that's going to help us once we go back and use the original function. The original function is 6xy equals 2 plus y to the power of 3. Take what we got for x and plug it in. So 6 times y squared over 2 times y is equal to 2 plus y to the power of 3. Okay. And now that our function is in terms of y, all we got to do is solve for y. This becomes 3y squared. Oh, actually, 3y cubed equals 2 plus y cubed. Okay, we'll subtract the y cubes. 2y to the power of 3 is equal to 2. Y to the power of 3 is equal to 1. Y is equal to 1. And that's your y value. But we have to find the coordinates of the whole point, right? So we still need x. So from here, we can go back to the original function and plug in 1. So step number 3. 6xy plus 2 plus, no, equals 2 plus y to the power of 3. Okay, plug in 1. 6x times 1 is equal to 2 plus 1 to the power of 3. So then 6x is equal to 3, and x is equal to 1/2. So there we go. So now we have one coordinate right here. We have the point has coordinates of 1/2, comma 1. All right. Okay. Let's check the rubric real quick to make sure I didn't miss any coordinates. This is question number 6, part C. Question 4, 5, 6. Part C. Yeah, that's it. It's perfect. It's perfect. So then the original question was, find the coordinates of a point on the curve at which the line tangent to the curve is vertical. So let me rephrase what I said. The point where the tangent line is vertical is 1/2, comma 1. Okay. Last one. Part D. A particle is moving along the curve at the instant when the particle is at the point 1/2, comma -2. Its horizontal position is increasing at a rate of dx dt of 2/3 units per second. What is the value of dy dt, the rate of change of the particle's vertical position at that instant? Man, there's a lot of complicated words here. But you know what? Take it one step at a time. And we're going to start by writing the original equation. So 2 plus y to the power of 3. We know at the instant when the particle is at the point 1/2, comma -2, the horizontal position is increasing at a rate of dx dt equals 2/3. What is the value of dy dt? So after reading the problem twice, we realize that this problem is an implicit differentiation problem. In other words, both x and y are functions of t. They're functions of time. We're going to be taking the derivative d dt. Okay, so how does that look? It looks like this. D dt of the left side equals d dt of the right side. Okay, so be careful, all right? The 6 doesn't matter because it's a constant. Okay, so now the derivative of x times y, it's the first times the derivative of the second plus the second times the derivative of the first. The derivative of 2 is 0, but the derivative of y to the power of 3, it's 3y squared times dy dt. Okay. Next, go ahead and plug in your points and your derivative. X is 1/2. Y is -2. Oh, I missed something. Dx dt. That's 2/3. 3 times -2 squared times dy dt. And there it is. We just have to solve for dy dt. Okay, let's go ahead and distribute the 6. This gives me 3 dy dt minus that's 4 times 2 is 8 equals 3 times 4 times dy dt. Okay. Let's go ahead and subtract 3 dy dt from both sides. And that's going to give me 12 dy dt minus 3 dy dt. Well, this now becomes -8 equals 9 dy dt, which gives us -8/9 as dy dt. And that right there is our final answer. And it looks like we are done with the 2023 FRQ part of the test. Perfect. If you, by any chance, find any mistakes that I might have made throughout the video, just go ahead and let me know so we can tell the others. Perfect. See you guys soon.